Assalamualaikum. Today I want to present ESSAY2 Computer Architecture and Organization. My name is Nur Ali Nadira binti Ahmad Sukri, number matric 16DTK20F2023. My friend is Nur Anisha Zona binti Adina, 16DTK20F2026, and other friend is Fatin Nodiana binti Muhammad Jalani, 16DTK20F2028.
Assalamualaikum, nama saya Fatin Nodiana binti Muhammad Jalani. Hari ini nak membentangkan main memory bersamaan dengan 128 megabyte, cache memory bersamaan dengan 256 kilobyte, 2/7 kali dengan 2/20 sama dengan 2/27, sama dengan 27 bit line. Word dia sama dengan 3 bit, sama dengan 2/3 dan sama dengan 8 data location. Satu data per location sama dengan 8 bit. 8 data per location sama dengan 64 bit. Cache memory pula sama dengan 25 kilobyte. 256 kali dengan 8 bit sama dengan 32K kali 64 bit. 25 kali 2/10 sama dengan 2/15, 15 bit line. Teks dia sama dengan 27 tolak 3 tolak 15 sama dengan 9 bit. 29 sama dengan 512. Memory will be divided to 512 block. Teks dia 9, line dia 15, word 13. Seterusnya direct memory access, iaitu DMA. DMA is system that can control the memory system without using the CPU. Nombor 2, DMA is ability provided by some computer bus architecture that allow data to be sent directly from an attached device to memory on the computer motherboard. Nombor 3, usually a specific partition of memory is designed as an area to be used for direct memory access.
DMA controller used in data transfer technique. DMA is a form of input-output in which a special module called a DMA module controls the exchange of data between main memory and input-output module. The CPU sends a request for the transfer of a block of data to the DMA module and is interrupted only after the entire block has been transferred. In DMA-based data transfer, the transfer operation is carried out by DMA controller, which acts as a master in the microprocessor-based system. The data is transferred directly between input, output, and memory, and a data transfer is controlled by either input-output device or DMA controller. Microprocessor does not participate in this data transfer method. The working data of DMA controller 8237 in this case is a typical computer with a processor. This controller is shown in the next figure.
Assalamualaikum warahmatullahi wabarakatuh. Today I would like to read about the question 2. The peripheral device such as the register controller will request the service of DMA by pulling the DMA request high. Then the DMA will put a high on its HRQ or hold request, signaling the CPU through its hold pin that it needs to use the buses. The CPU will finish the present bus cycle, not necessarily the present instruction, to respond to the DMA request by putting high on its HDLA, hold acknowledge, thus telling the 8237 DMA that it can go ahead and use the buses to perform its task. Hold must remain activated as long as DMA is performing its task.
DMA will active DAC which tell the peripheral device that it will start to transfer the data. DMA start to transfer the data from memory to peripheral by putting the address of the first byte of the block on the address bus and activating MEMR terabyte reading by the byte from memory into the data bus. It then activates low to write it to the peripheral. Then DMA decrement the counter and increment the address pointer and repeat this process until the count reaches 0 and the task is finished. After the DMA has finished its job, it will deactivate HRQ, signaling the CPU and it can regain control over its bus.